Okay, I'm going to attempt to do our first video review. I have the review sheet out here. Um, this is on chapter 4 with congruent triangles. And the first one says two triangles have the following pairs of congruent sides. Segment BD is congruent to segment FJ. Segment DG is congruent to segment JM. And segment GB is congruent to segment MF. Write the congruent statements for the two triangles. Well, personally, the easiest thing for me to do right off so I can see it is to draw the triangles and see exactly what segments they're talking about. And they aren't necessarily these lengths. I'll just say all figures are not drawn to scale right off, but it helps me to see it. And then once we see that all three sides are congruent to each other, we can say, therefore, triangle BDG is congruent to triangle FJM. Okay, so I just drew my triangles over here, put my tick marks on what they said was congruent, and then there's my congruence statement. It says triangle QRS is congruent to triangle TUV. Name the angle or side that corresponds to the given part. Well, once again, I drew the triangles so that I could see them, which made it much easier. So at angle Q, I noticed that angle T is its congruent. So I have angle Q is congruent to angle T, or really it corresponds to it. So segment RS corresponds to segment UV, and angle S corresponds to angle V. Okay. The next one says state the postulate or theorem that can be used to prove the triangle's congruent. If you cannot prove the triangle's congruent, write not enough information. Well, on number 6, we see that we have three sides congruent, and even though they've got them a little whopper-jawed, we can see that each side is congruent to each other. So this would be side, side, side. Okay, and that's all you would have to put is side, side, side. Now the next one, we see it's a little bit more similar. They don't have it as so skewed from each other that we have to kind of pivot them around and have a better spatula awareness. But we see that this side is congruent to this side, this angle is congruent to this angle, and then this side is congruent to this side. So by saying that, we have side, angle, side. And that is your reasoning behind why you say they are congruent. Now the next one we have, it's a little bit different, and you would need to turn it over. If you'll notice, this one has a leg and the leg, and we think, oh, okay, and then this angle and this angle. But if you'll notice, we have the hypotenuse side right here, and over here it's the other leg. So don't get that confused and just quickly say, oh, we have side angle, or come up with something like that, which that doesn't really even work out anyway. But just notice that even though we have these tick marks here, those are not congruent sides. So this is not enough information. Okay. And then the next one, number 9, that one's pretty easy. Angle, side, angle, angle, side, angle. So we have angle, side, angle. All right, let's go down here to number 10. And it says, use the diagram, tell why each statement is true. And what they're wanting you to do here is to tell us a postulate or a theorem that proves that these are congruent pieces. So the first thing we're looking at is angle A to angle C. And if you look, they're alternate from each other, and they're also interior angles. So it's the alternate interior angle theorem. Okay. The next one says angle AXB is congruent to angle CXD, And if you'll notice, these are vertical angles, so we know that those angles are congruent. So this is the vertical angles are congruent postulate. Okay, that's our reasoning. Now, the next thing we're looking at is triangle ABX is congruent to CDX. And I know y'all are all going, oh, angle, side, angle, angle, side, angle. And that is exactly what it is angle, side, angle. Remember, these are vertical angles, so we know they are congruent. These were congruent, and these two sides are congruent. All right, let's move down and look at our proof right here. So I really need my glasses on. My eyes are tired. Our first one that we were given was LM is congruent to NO. Okay, right here. And then angle LMO is congruent to angle NOM. Now, we know right here that that side is congruent due to the reflexive property. So please remember that. Y'all always forget about that when they share that diagonal, that is the reflexive property, that OM is congruent to MO by the reflexive property. So let's go ahead and start. So what we have first, and I'm just going to try to write it over here to the side. And we always want to start with our given. So we have segment LM is congruent to segment NO, and that was given. We have angle LMO is congruent to angle NOM, that was given. We know that segment OM is congruent to segment MO due to the what? Reflexive property. And I'm just going to put prop there because I don't have a lot of room to write. Let me move this up some. Okay. And then we can say that, what are we looking for? Triangle LMO is congruent to triangle NOM due to what? What are you thinking? Look at these right here. Remember, they were given. So we can do side, angle, side. Yes, Miss Smith, we can. Side, angle, side theorem. Okay. And that was like a 1, 2, 3 situation. So that wasn't very long. Down at the bottom, it says 14, reasoning. Explain why it's not possible to have a side-side angle congruent postulate or theorem. Draw a picture if necessary. I talked with a couple of students about this today that came in for Cub Academy to get some extra help with this before our test tomorrow. But it says a triangle can have two sides and a non-included angle congruent to another triangle, but the hinge effect of one side makes it possible for two different triangles to result. And I specifically remember talking to one student about that I could have something that looked like this, and maybe this was 5 and this was 5, and maybe this was an obtuse angle. But then I could also have something like this and like this, where this side length was 5 and this one was 5, but this may be an acute angle. Okay? That's why we don't have side angle, because we could change these, okay? That could make this whole situation different for both triangles. So just think about that. And that's what they mean by the hinge effect. And I say that with my hands. I'm sitting here doing it with my hands like y'all could really see me. That you could change that so it doesn't necessarily mean that the angle is congruent to that. So nothing that hard is going to be on the test, but please just be aware that is why. Let's flip the page. Go up to the top. It says, do you know how? Okay, so let's look at the first one. It says, explain how to use congruent triangles to prove each statement true. So right off the bat, all we're really doing is little tiny short proofs where here's our given, right here and right here. And then basically we just have to make a statement. And this is that CPCTC, okay? So let's look at our first one. We have MN is congruent to PO and O is congruent to MP. Of course, right here, don't forget this. I know I don't have anything to put it, but it's back on itself for reflexive. So we have triangle, or I'm sorry, angle OMN is congruent. No, I am doing triangle. Triangle OMN is congruent to triangle MOP by the side rule. Here's our side. Okay. And then angle OMN, this is what we want to prove. Prove this. Okay. Is congruent to angle MOP by CPCTC. All right. So congruent parts, corresponding parts of congruent triangles are congruent. That's our reasoning. Excuse me. All right, so let's look at number 2. We have a right triangle, and when we have a right triangle, you know what they like to use. What is that? They like to talk about the HL theorem, which we don't know that this hypotenuse is congruent. They don't tell us, so think about that. They didn't tell us that these were congruent to each other, but we do know that this is. So due to reflexive, think about that. PO is congruent to OP due to the reflexive property. And then we have SO is congruent to OR. So we have side, and we know that this is a 90-degree angle. So we have what? Side, angle, side. Yes, ma'am, we do. So you would say triangle PSO is congruent to triangle PRO by the SAS theorem, side, angle, side. And then we would say, therefore, remember, this is what we're trying to prove right here. Segment SP is congruent to segment RP by corresponding parts of congruent triangles are congruent. Okay, there's that one. All right, let's move on to number 3. I will tell you that there are several like number 3 and 4 and 5 and 6 on the test, and then one kind of like number 7 where you don't have to fill in all the stuff, just little pieces of it. So let's go ahead and do number 3. And it says find the values of x and y. So we want to know the degrees. Now this happens to be an isosceles triangle. So we know that the isosceles triangle theorem says congruent sides, the opposite angles are congruent. So if it's 50 here, we know that this side is also 50. So we know x equals 50 degrees. Well, we know the included angles of a triangle, the area, or the, I apologize, my nose is so stopped up, guys, I'm sorry, is 180 degrees, and we know 50 plus 50 is 100, subtract it from 80, so we know y is 80 degrees. Please don't make that harder than it is. Number 4, we want x and y. Now, this is a equal angular, so we can assume that it is also what? Equilateral. So we say all these are the same, so we're going to set these equal to each other. Okay? And then we just do algebra. So I'm going to subtract 3 from both sides. Remember, if you do it to one side, you have to do it to the other. So y is 5, and it would be 5 units because they don't tell us what it is. Here, we're going to add 5 to both sides. This cancels or it becomes 0. We have 2x equals, what is that, 13? Divide both sides by 2 to isolate our x. X equals 6.5 units. Okay? Pretty simple. Just remember what you know about triangles. That will help you. Okay, let's move on up here to number 5. Now let's think about this. They share this angle. Okay, remember we talked about shared sides, shared angles, and then they share this side. So let's go ahead and talk about it. So if we pulled them apart, we have what? Angle, side, angle, angle, side, angle. And that one was pretty simple. You really didn't have to pull it apart. That 90-degree angle there makes you want to think the HL theorem, but due to the fact that we have a shared angle, a side, and an angle, we can use angle, side, angle. So you would say triangle ABE is congruent to triangle ACD by angle, side, angle theorem. All right, so let's look at number 6. Now this one's a little bit better. I can see this one a little bit better. You could pull those apart, set them up, and it looks a little bit easier. We know that they share this side. So look at there. Side, angle, side. Okay, side, angle, side. So you would say triangle ZXW is congruent. I don't have enough room to write. To triangle YWX by the side angle side theorem. Just remember they share this angle right, or I'm sorry, this side right here. That's where the other side comes from. So we have side angle side, side angle side. All right, number 7. This is the kind of proof I like for y'all to look at because it doesn't just give you all the statements and you have to make up every reason and let you go back and forth. So at the beginning, we have segment AE is congruent to segment AD, and angle B is congruent to angle C. So we know these two are congruent, and then AE is congruent to AD. That, we can kind of see that's got our tick marks also, but they told us. And we want to prove that EB is congruent to DC. So let's look at this. AE is congruent to AD and angle B is congruent to angle C. Well, of course, that's just our given. Okay. Reflexive. What is something that they are sharing that we could turn it back on itself? Well, that would be angle A. So we would have angle A is congruent to angle A. I don't know why I put another congruent sign there. Due to the reflexive property of congruence. So remember, when it's turned back on itself, that's the reflexive property, and that can work for angles or side lengths. So then we have triangle ABD is congruent to triangle ACE, and that is by, let's look at that. I apologize. Angle ABD, and then we have angle ACE. And what did we look at? We have angle, angle, side. So we have angle, angle, side. Angle, angle, side. Okay? Don't get those mixed up with what they belong with. Because me, myself, I wanted to say angle, side, angle, but this is the complete side. The side that we have is the base down here. And then that's the base of the other one. So take that into consideration. So then we have AB is congruent to AC. And why do you think that is? Because corresponding parts of congruent triangles are congruent. CPCTC, that little tongue twister we have. Therefore, okay, and this goes to our proof, our very last statement is always our proof. We have segment EB is congruent to segment DC. And that's by the segment addition postulate. And that's from a while back, so that's something we don't see as much. Please know that on your test tomorrow, you can use all theorems from past tests. plus Chapter 4 theorems. It's going to focus on Chapter 4 theorems, and there will only be, I'm pretty sure, I think it's only one proof on the test. So if you have any questions, send me a message and remind. I hope this has helped you. Like I said, this is my first little video, so be nice, and I will see y'all in the morning. Good luck.